Before we start sketching straight lines or linear graphs, we need to be able to plot points on an axis. Now, the points that we plot are called coordinates. Take a look at the axis in front of you. It's a cross. So our values go in the positive direction. They go in the negative direction. So that's the positive direction of x and the negative direction of x. They go in the positive direction of y and the negative direction of y. Now, when we plot a coordinate on our axes, we always state the x value first and then the y. So if you had a point 3, 5, that is your x value 3 and your y value is the 5. So we know that we have to go across 3 places on the x-axis and then up 5 places on the y-axis. Now, in the last section, we were looking at distance-time graphs, where distance was on our vertical axis, time was on our horizontal axis. And we said that they were both variables. Well, every straight line graph has 2 variables. Often, it is your y and your x value. And a straight line graph will take this format, y equals mx plus c. Let's have a look at examples of that here. Y equals 2x minus 3. Y equals minus x plus 7. M is your gradient and c is your y-intercept. Y and x are your 2 variables. And we'll be having a closer look at gradient and y-intercept later on down the track. In this example, we're asked to plot the graph, not sketch it, plot it. So when we're plotting a graph, we take different values of x and find their y value by using the rule. And then they want us to sketch the graph. So let's fill in this table first. When this is our rule, y equal to 2x minus 1. And I'm going to start with my x equal to negative 1. So when x is equal to negative 1, I get y equal to 2 times minus 1, take away 1. 2 times minus 1 is minus 2, take away 1 is minus 3. So that's my y value. Then my x value is 0, and I get y is equal to 2 times 0, take away 1, just substituting it into your rule, and you get negative 1. And the last one is when x is equal to 1, substitute it in again, 2 times 1, take away 1 is positive 1. Now, there's a couple of things I want to point out here. We can see from our rule that our gradient is 2, which means we're going up 2 and across 1 each time. Well, have a look at our y value. What's happening here? If I go from minus 3 to minus 1, I'm going up by 2. Minus 1 up to positive 1, I'm going up by 2. So if you know what your gradient is, as your x values go up by 1, your y values are going up by 2. The other thing, if I was going to write these as coordinates, I write my x value first, which is minus 1, and my y value was minus 3. Over here, my x value was 0, my y value was minus 1. For this one, x was equal to 1, y was equal to 1. So they are the 3 coordinates that I found to help me now plot this graph. So I've set up my axes here. On my y-axis, I've gone up by 1s, up to 3, and then down to negative 3. And on my x-axis, I've also gone up in 1s because I'm dealing with some fairly small numbers here. Now I'm going to plot these points. This first one, when x is equal to negative 1, y is equal to negative 3. So negative 1's all the way down there, y negative 3 there. So the point where they meet is that point there. For the next one, when x is equal to 0, y is equal to -1. So again, x equals 0 all the way down there, y equals -1 there. Where do they meet? They meet or intersect on that point there. All right, and then the last one that we're going to do is when x is equal to 1, which is all the way along there, y is equal to 1, it's all the way there, they intersect there. So I've got 3 points. I'm going to label those points. So 1, 1. The green one is 0, -1. And the first one that I did was -1, -3. Remember, the x value goes first, then the y. So now the only thing left to do is to draw a straight line through those points. And I'm going to label that straight line. I know that it is y equal to 2x minus 1. So that is a straight line that has been drawn because it has been plotted first. An electrician charges $50 for a service call and $60 an hour for labour. So what this is saying is that before the electrician even comes out and starts looking at your issue, he's going to charge you $50 just to come to your house. So it's $50 and then $60 per hour. Now I could write that as the cost is equal to, well, straight out it's $50 plus $60 for every hour. So if I call T for time, T for hour, that's what my rule would look like. So every hour that he's there, it would be 60 times the amount of hours plus that initial $50. So therefore, what would it be for 1 hour? Well, I'd be substituting T equal to 1. So 60 times 1 is $60 plus 50 is $110. And then the 2 hours, obviously it's going up another $60, so it's $170. Going up another $60 for 3, so that's $230. For 4 hours, $290. And then for 5 hours would be $350. So not bad money, is it? Now in part B, we're asked to plot the graph of cost against the number of hours. As a general rule, time will always be on your horizontal axis. So time in hours and the cost is in dollars. So don't forget to let people know all the information that you've got. Well, the first one is 1 and 110. So when time is 1, the cost is 110. So my scale, if you have a look at it there, is going up in 50s on the vertical axis and going up in 1s on the horizontal or time axis. Okay, so 2 and 170. Again, because my scale is so large on the vertical, it's always going to be a roundabout. And so what I do then is I go through and I plot all those points, and then I'm going to draw a line through them. So you can see the points there have been labelled. And so now my last step will be to draw the line through them. Now remember, we know that before he comes, he charges $50. So we know that we're going to start at 50 and then we'll just draw our line through all of those points. Now don't forget to label those coordinates on your graph that you've gone through. All right, the next bit is asking us to use the graph. So now that we've got the graph, it wants us to use the graph to find the cost for 4.5 hours work. So by drawing a line up from 4.5 up to our graph and then across to our vertical axis, you can see there that, again, my scale is fairly large, but you can see that the cost is around about $310. That's just reading straight from a graph. Part 2 says find how long the electrician will work for $260. This time we're starting on the vertical axis at $260. $60, and we're going across to our line, and then once we hit our line, going down to our horizontal or time axis, and we can see there that it is around about 3.5 hours. So all of this is just from reading from our graph. We do not need to substitute it into our rule, we just need to read it from our graph once we have our straight line.